Welcome to part 2 of trig identities, sum and difference formula. Now we're going to take a function that looks like it's separated and work in reverse. So this time we're going to look at it and say a sine of what? A sine of u minus v. Well, what would that u and v be? Well, here's my u, here's my v, my u, and my v. So I could rewrite this as sine of 42 degrees minus 12 degrees, which will get me sine of 30 degrees. Well, what is the sine of 30 degrees? Whether you punch it in your calculator or you use your trig chart, you'll find that value is 1/2. Go ahead and attempt this problem. Press pause and then come back to it and I'll work the problem out for you. Well, welcome back. If you actually did what I said, you tried this problem, you should get an answer of radical 2 over 2. How that is gotten is we would have a u of 25 and a v of 20 degrees, and this time we're working with cosine. So cosine of 25 degrees, and what does this subtraction mean? Well, in the formula this means that I really have a cosine u plus v. So I'm going to add the 20 degrees. That's by definition. So if we work this out, I see I have cosine of 45 degrees. And again, looking upon our trig chart or through the memorization that we may already have, it is radical 2 over 2. We'll now go to the last couple problems I want to look at for today. And this first one says solve the trigonometric equations for the interval 0 to 2 pi. So we're including 0. We're including 0, and we're going up to 2 pi, but not including that. So number 9 is looked at again in the lieu of we're dealing with sum and differences. And as we take a look at this one, we clearly see that we have a sine of pi minus 4, and working that out, we will have the following. Don't like it, never mind, wrong problem. I didn't want to be this far down. We need to be here on number 7. I don't want to rewind and try to start this all over again, so we'll just jump here. Sorry, we'll go back to number 7. Here we are going to prove. I thought we were on proofs. We're going to prove, again, we could use the word verify, that this in fact is true. So I'm going to put my dotted line there, make sure I work on one side or the other. So in my proof of this, I'm going to look at my identity and see that I have cosine of u, which is pi over 2, times my cosine of x, and I will need just a tad more room, so I'll kind of angle this. I'm going to need a addition of sine of pi over 2 and sine of x. Now, what is cosine pi over 2? We recognize that is 0. 0 times cosine x. Doesn't matter at this time, it is gone. So we have a positive value. The addition now represents a positive value of sine pi over 2, which is 1. And we're going to multiply that by sine x. So my value is sine x. How is that shaping up for what is on our left side, or our right side rather? It shapes up beautifully. I leave this one for you to verify. Number 8. Give that a shot and then unclick pause and I'll show you what the answer is or how I approach that. Well, I hope you had success. This time we're working with sine. And because we're working with sine, we'll think of the sine identity looking like sine of u and cosine v, and cosine u and sine of v. And now what is the relationship with this one? We need a subtraction or a difference in between. Again, go ahead and verify that on your sheet, but that's what we have. Now, what do we get? We get a sine x, and then we have a cosine of our pi over 2. Subtract a cosine x multiplied by sine of pi over 2. Working this problem out, we'll see that cosine of pi over 2 is 0. And so sine x times 0 is 0, so we don't need to consider that. This time, however, we do have a negative cosine x multiplied by 1. So our answer is negative cosine x. Now, does that get us back to the original? Most certainly does. Okay, that's it for the lesson. The couple problems I would like you to do are the following. So now what I would like you to do is try these 3 problems and have them ready for me tomorrow. The exact value of tangent 75. That is going to take a little bit of work because we're working with a fraction in our identity. But please make sure you attempt all 3 of these. But my mom always says that you should work hard and do everything, and if you have a question, you can always go in and ask it. Well, thank you very much. That was our very own water boy here at STMA. He does fine work with the football team, but we're talking about mathematics. So this first one might be a little challenging, but I think you can do it if you take a little time with it. The evaluate cosine pi over 12. Remember, we're trying to get that 12 to be something over 4, over 3, over 2. So we'll be able to reduce that. Look back in the examples I gave you. And finally, proving that sine of x minus 3 pi over 2 equals cosine x. Look and view your trig identity here. Remember that you are working solely on the left side to get our cosine x. So why don't you pause for a moment, get these written down, and we'll see you tomorrow. Thanks and have a great day.